All right, guys. This is video number 2 on classifying matter or our basic um, lecture about matter in biology. So previously, we talked about pure substances and elements and chemical formulas and atoms and these things. Today, in this video, I want to start off talking about the atom itself. There's a few things about atoms that I think students should know. Maybe some of these things you already do know. Um, but for example, the atom is the smallest unit of matter, right? So if you have a block of gold, I don't care what you do to that block of gold. You can melt it, you can freeze it, you can, you know, pound it with a jackhammer. Whatever you do to that block of gold, you're still going to have gold atoms, no matter what. Okay, it's the smallest unit. Now, typically, when we draw pictures of atoms, we draw them something like this. This is called the Bohr model of the atom. Let me write that here real quick. It's called the Bohr model, B-O-H. Drawing with my mouse here. It's called the Bohr model. Anyway, Bohr models basically depict um, just the different components of the atom. For example, in the middle here, we have what we call the nucleus of the atom. Okay. And in that nucleus, there are two particles, right? There's what we call protons. Those are in that nucleus. And there's also neutrons. Now, you probably know that protons are positive and neutrons are neutral. Okay, if you don't know that, then you should know that. Then you have these little dots, right, all around the nucleus. Those are the electrons, and those are negatively charged. Now, one thing I want you to kind of understand about this Bohr model, okay? And you'll see that in the nucleus there you have that's where all your protons and neutrons are. But you'll see how the electrons are kind of arranged around the nucleus in these kind of circular, we call them orbits or orbitals. There's a lot of chemistry behind this, and I'm not going to get into that with you. Next year in chemistry class, you'll learn more about this. But each one of these orbitals can only hold so many electrons. Okay, and I want you to remember this. The first orbital can hold a maximum of 2 electrons. That's the most that it can hold. The second one can hold a maximum of 8. Okay, and the third one can also hold a maximum of 8. Okay, so if you just remember that, it'll come in kind of handy for some of the things that we talk about a little bit later on. So just kind of remember that. So, I mean, this particular atom here, if I can get my little laser pointer back. Okay, this atom here, you'll notice how we have 2 electrons in the first orbital. We have 8 in the second, and that's the most that there could be. So there's 10 there. You'll notice in the third that we have 2 out here. Now that's okay. I mean, it can hold up to 8, but there just happens to be 2. So that means you have 2 plus 8 plus 2 more. So there's a total of 12. So there's 12 electrons, 12 negatives that are kind of floating out here around the nucleus. Now, this very last bullet here where it says atoms are electrically neutral, that's where these charges come in. So I want you to think about this. If you've got 12 negatives, right, 12 electrons, then how many positives do you have in the nucleus? Right, you've got 12. The number of positives and the number of negatives are equal. They kind of cancel each other out. The neutrons don't have any charge, so they don't even matter as far as balancing the charge goes. But the number of protons and the number of electrons are going to be equal to each other. That's something important to know. Okay. All right. How do I advance my screen? There we go. Okay, now the mass of an atom. Now these 3 particles that we just talked about, protons, neutrons, electrons, they all weigh something. They all have a different mass. And there's two things that I want you to kind of remember, okay? Protons and neutrons, which are located where again? They're in the nucleus. Those particles are extremely heavy. They're very massive in comparison to the electrons. And I always use this analogy that protons and neutrons are like bowling balls. They're like really heavy. And electrons are like feathers. Okay. If you had a container filled with bowling balls, so you had a garbage can, and in it you threw like 10 bowling balls in it. I think it would weigh like 150 pounds, right? If you dropped a feather into that container, would that really change the mass of those bowling balls? Not really, right? So electrons are so light compared to the other two particles that we don't even count it for the mass, okay? So I want you to kind of remember that. You know, all the mass of an atom is in the nucleus. Why is that? Because that's where all the bowling balls are. That's where all the protons and neutrons are, okay? There's a term here, it's called the atomic number. The atomic number is how many protons there are. In fact, you know, on a periodic table, like when you look at an element key, like whenever you see this whole number, like for lithium, it's 3. That represents the atomic number. Okay, so there's 3 protons in a lithium atom. If you look at your periodic table, find carbon. You know, carbon, the atomic number is 6, so there's 6 protons. You know, magnesium, you know, the atomic number is 12, 12 protons. Uranium, I know a whole bunch of them. I used to teach chemistry too. Uranium is 92. There's 92 protons. So think about this. I mean, the greater the atomic number, the heavier the atom is going to be. You'll notice on that periodic table, as you go left to right, those atomic numbers get bigger and bigger and bigger. Okay, that's because the atoms are getting heavier and heavier and heavier. Now, there is another term that I want you to know. It's called the mass number. The mass number is the number of protons and neutrons. So it's kind of like all the bowling balls, not just the protons. Now, I want you to be kind of careful because when you look at an element key, you see that other number, you know, for lithium, it's 6.941, whatever it is. You'll notice that this number is a decimal, okay? This number is not the mass number. It's not what that is, okay? This is what we call the atomic mass. It's something completely different. For this class, this number means nothing to you, okay? I want you to pretend that it's not even on your periodic table, all right? Because we're not going to use it for this class. Next year in chemistry, you're going to use it for a whole bunch of stuff. But in this class, we don't even worry about it, okay? So the only number that you really need to worry about is this number, which is the atomic number. And you do have to worry about the mass number, but just remember that this number is not on the periodic table. On this key, the mass number is not there, okay? So that's something that you have to kind of remember. So why would we need to know the mass number at all? Well, here's why we need to know this. These are what we call isotopes. Isotopes are atoms of the same element. So for example, these are all lithium, but they have different numbers of neutrons. So if you look here, this is what we call lithium-6. And I want you to look at the picture below the symbol here. You see these little balls, you got some blue ones and some brown ones and some red ones. So this is the atom. This is a lithium-6 atom. You'll notice that there's 1, 2, 3 protons. Right? That's why it's lithium. If there wasn't 3 protons, it wouldn't be lithium, right? You'll also notice that there's 3 red dots out here. Those are electrons, right? Because remember, the positives and the negatives have to balance each other. So there's 3 positives, there's 3 negatives. You'll also notice that there's 3 brown ones. These are the neutrons. okay? Now think about what this number here means. This is the mass number, right? The mass number is the protons and the neutrons. So in lithium-6, there are 6 protons and neutrons. If you don't believe me, count them up. In lithium-7, again, this is lithium because there's 3 protons and there's 3 electrons too. But there's 7 protons and neutrons because we have an extra neutron here. This is lithium-8. Again, it's lithium because there's 3 protons and 3 electrons. But there's 5 neutrons. So 5 plus 3 gives us 8. So these are what we call isotopes. I want you to think about the differences between them. Okay, one difference is they have different numbers of neutrons, right? Another difference is they have different masses, right? They have different mass numbers. This one has a mass number of 6. This has a mass number of 7. This has a mass number of 8. So even though they're all lithium, they're not necessarily the same lithium. It's like if you went out into nature, not that you would ever be able to do this, but if you just like scooped up some lithium into your hand, you got a whole bunch of lithium atoms. Some of those lithium atoms are lithium-6, some of them are lithium-7, some of them are lithium-8. All right, so there are different isotopes of the same element. I want you to know what that means. All right, the last thing I want to talk about today is bonding. For this class, we're going to keep it really simple. There are 2 different types of bonding: ionic bonding and covalent bonding. And the first one that we're going to talk about is ionic bonding. Now, ionic bonding happens when electrons donate, or let me rephrase that. Ionic bonding happens when atoms donate electrons to other atoms. Okay, so like why would this happen? I want you right now to get out your periodic table or pull it up on your computer screen or whatever. I've got one here to kind of show you as well. All right. And I want you to find 2 atoms. I want you to find the element sodium. Okay, it should be on the left-hand side of the periodic table, Na. And I want you to find the element chlorine. Should be on the right side, element number 17. Sodium is element number 11. Okay. So I want us just to think about sodium. Sodium is atomic number 11. So there are 11 protons in that nucleus. Okay. There's also 11 electrons. Now I want you to remember what I said earlier. Those electrons are arranged in a certain way, right? Remember those orbitals? Now, do you remember how many electrons can go in that first orbital? 2, right? 2 electrons. There's 11 total for sodium. 2 of them can go in that first orbital. The second orbital, remember how many we can put in there? 8, right? 8 can go in there. So we've got 2 in the first, you got 8 in the second, and you got 1 more, right? Because there's 11 total. And that one lonely little electron goes in this final orbital. Now, chlorine, on the other hand, chlorine has an atomic number of 17, right? So there's 17 protons in the middle. You don't see them all there, but they're in there. There's also 17 electrons, right? 2 go in the first, 8 can go in the second, and then 8 can go in the third, but there's only 7 left for chlorine. So for chlorine, it's 2 and then 8 and then 7 in that outer level. Now, before I get into the bonding, okay, here's a term here called a valence electron. Valence electrons are not just any electron. They're electrons that are in the outermost level, or the outer shell, or the outer orbital, we call that. So think about sodium, right? Sodium has 1 valence electron. Chlorine has 7 valence electrons. There's one thing about atoms that you need to know. Atoms don't like it when their outer level is not full. They don't like it. They're not very happy. So sodium here, seeing that there's only one electron in its outermost level, it is not a very happy atom right now. It wants to do anything that it can to get rid of that one electron. Okay. Now, it could gain 7, I guess, right? If it gains 7, then that whole outer level would be full. But it can also lose 1. If it loses 1, then that outer level gets eliminated, and then the second level will be the full one. So think about what sodium would rather do. Would it be easier for sodium to gain 7 or to just get rid of 1? Of course, it would be easier to get rid of 1. So sodium, in the worst way, wants to get rid of that one little electron. Okay. Now, chlorine, it has 7 valence electrons. Again, it's not happy, right? It wants that full outer layer. So chlorine could get rid of 7, right? Or it could gain 1. So obviously chlorine wants to gain 1. So these two atoms are like a perfect match. I mean, they are like in love with each other, right? Because sodium wants to get rid of that electron, chlorine wants to gain it. And by doing that, they form this nice little bond together called an ionic bond. That's what ionic bonding is all about. It's all about transferring electrons so that atoms can be healthy. Okay. So a summary of ionic bonding results in atoms losing or gaining electrons. Now, when this happens, I'm going to go back to this real quick. I'm going to go back to sodium here. Okay. Sodium normally, right, has 11 protons, so 11 positives, right? It also has 11 negatives. Again, I'm writing with my mouse here, okay? So that's why it's neutral, right? So when sodium gets rid of that electron, it's losing an electron. Think about what that's going to do, right? If it loses an electron, it's still going to have 11 positives, right? It's still going to have those. But if it loses an electron, then it's only going to have 10 electrons, right? So think about those numbers. They're not balanced anymore, right? You got a positive 11 and a negative 10, right? So what that's going to do is it's going to cause sodium to have an extra positive. It has one more positive than negative. So instead of being a sodium atom, it's going to be a sodium ion. It's going to have a positive charge to it. Chlorine, on the other hand, chlorine is going to be gaining an electron. So if it gains an electron, it's going to become negatively charged. Now, what do we know about opposites, right? Opposites attract each other. All right, so there's a nice little bond that happens all because those ions end up forming. Ions are atoms with charges. That's what they basically are. Okay. All right, now the last type of bonding is what we call a covalent bond. Covalent bonding happens when atoms share electrons. Now, I'm going to give you a really great example of covalent bonding, and that's water. All right. So look at your periodic table. Find hydrogen. Right. Hydrogen has 1 electron. So we're gonna put that little electron right here. All right, there's this little tiny electron. This guy up here, this hydrogen atom, he's got 1 little electron too, right? Now I want you to find oxygen. It's element number 8. So oxygen has 8 protons and 8 electrons, right? So remember how those electrons are arranged, right? How many of those 8 electrons go in the first orbital, right? 2 of them. And how many go in the second? There's going to be 6. So oxygen has 6 valence electrons. So I'm going to write them like this. I'm going to put 2 of them here. There's 6 total valence electrons. I'm going to put 2 of them here. Okay. I'm going to put 1 over here. And there's a reason why I'm doing this. I'm going to put 1 of them over here. Okay. So let's take a look at let's look at all of these atoms, right? Hydrogen has 1 electron. 1. Do you think hydrogen is happy being by itself? Being or having that 1 electron? No, it's not happy. What would make hydrogen happy? It could get rid of 1, but if it gets rid of 1, then it won't have any. So that's not very good. But remember that first orbital, what's the maximum amount that could go in there? Is 2, right? So if hydrogen gained 1, then it would be good. Okay, so that's what hydrogen wants, to gain 1 electron. Now oxygen has 6, right? It has 2 in the first, it has 6 in the second. So what does oxygen want to do? I mean, does it want to get rid of 6? Or it could gain 2, right? So it wants to gain 2. So there's a problem here. We've got these 2 hydrogens that both want to gain 1, right? And then you've got oxygen that wants to gain 2. So it's almost like you got a bunch of little kids fighting over their Halloween candy. Let's say you got a big old fat Snickers bar, and every kid wants it. None of them want to share it. They just want to, they just want to all take it themselves. So there's no way they can just take electrons from each other. So the best thing to do is to share them. So what ends up happening in a water molecule is these 2 electrons here end up getting shared between the water molecule. And the same thing down here. These 2 electrons end up getting shared. So if you think about this, if that happens, if the sharing occurs, this hydrogen here will have its 2 electrons because they're being shared. This hydrogen will have its 2 electrons. And then this oxygen will have 1, 2, 3, 4, 5, 6, 7, 8. That's what the oxygen wants. So this type of bonding is called covalent bonding. It happens when all the atoms share the electrons, whereas in ionic bonding, the electrons are like given to other atoms. There's a difference. All right, if this is tough, watch it again, okay? Because I know there's a little bit of chemistry here, but we do have to understand the different types of bonding. All right, guys, I'm going to leave it here for today. I will see you soon.